Okay, welcome back to part two of Rate of Change. We're going to talk further about the skateboard situation. And in this case, we're looking at sections A, B, and C on the graph. How far does she travel? How much time? And then questions 3 and 4 deal with the whole graph. So take a moment and answer those questions. Okay, question 1. How far did she travel? In A, she traveled 1 foot. In B, she did not travel. In C, she went 5. How much time was it elapsed? In A, she elapsed 4 seconds. In B, 2. And in C, 5 again. So I must count that wrong. 4. 4 seconds went by for C. In 3, when was she the slowest? Well, that's in B. She didn't move at all. Okay, did not move from the motion detector at all. When was she the fastest? Well, that's in section C, as she increased pretty rapidly. Well, we're going to move on here. And we're looking at this case. Can we find the ratio between the two numbers? And what is that ratio called? Between the distance that she changed by the seconds that she changed. Well, it is called the rate of change. And rate of change is everywhere. It can be in a roller coaster. It can be in your speed. It can be in how fast a cheetah is, how fast an airplane is going, or the speed of the water, the velocity of the water. It's all over the place. The definition, rate of change is the change in the dependent variable divided by the change in the independent variable. Okay, another way to think of that as the change in the y to the change in the x. What are the dependent and independent variables? Dependent variable, again, is the numbers in the range. You get those answers depending on what you put in, which is what we call the independent, and that is the domain. So we have 3 questions here. We want to find the rate of change for these questions 1, 2, and 3. Okay, 1, 2, and 3. And I'm going to give a chance to kind of work on that yourself, answer them on your exam, and then you can check them in just a moment. Okay, the rate of change between day 1 and day 2. Well, that's 15 to 1, which is $15 per day. And that's how we would say that rate of change. Between days 3 and 4. There again, that's $15 per 1 day. $15 per day. And just written as a fraction there instead of putting the word per in there. And question 3, rate between days 1 and days 4. Well, that's 60 in 4 days. I'm sorry, between day 1 and day 4 is 45, and there is 3 days. There again, when you divide it, it becomes $15 per day. That would be the rate that they charge. Well, rate is how fast you are traveling. For example, for me to go back to Ohio, it's how fast I would be traveling. It says here, it is important that you notice the units for the y and the x. In this case, each block is 50 miles going vertically in the y, and each one represents 1 hour going horizontally, the x-axis. Now let's go back to the skateboard format. Okay, it says find the rate of change for sections A, B, and C. Again, you'll answer the exception questions, and then we'll check. Okay, we want to find the rate of change for this particular graph. Write down in Zamshin what sections A, B, and C, what you think their rate of changes would be. Well, their rate of changes are A, 2 feet to 3 to 3, so it's 2 feet per 3 seconds. In B, it's 0. It's not changing at all. In C, it's 2 feet to 6 seconds, which is 1/3 feet per second. Remember, you must simplify your fractions. Remember to simplify your fractions. One more graph here. Mr. Morgan is racing with Miss Morgan. As you can see, I kind of ran into a tree and I'm out of the race. Well, we want to continue here. So find the rate of change between each set of points. Describe what is taking place. Well, you get a chance to actually do that. So in Zamshin, answer the questions, what is taking place, and then we'll go through and check your answers. Okay, in the first section, A to B is 50 to 10 or 5 miles per second. The speed is increasing. In the next section, B to C, there's no change. The rate of change is 0. They are going at a constant speed at this point. When we look at C to D, they must be braking or decelerating. Maybe there's a curve. So from C to D gets negative 30 to 5 or in 5. So it's negative 6 miles per second. You're decreasing again. And D to E, you're increasing there. And we have an increase of 10 to 15 seconds. So it's 2 miles per hour per second. Again, you're accelerating. And finally, E to F, the race must be over. They go from negative 30, they go down 30 in 5 seconds, and that would be negative 6 miles per hour per second. Again, they are decreasing. So the exit ticket is right here. It is found on exitticket.com, and we will go through that. Their homework is on page 286, 1 through 6. There is a PDF for you to work on that assignment on Classroom. If you have any questions, feel free to ask. Thank you.